righty, this is going on page 53 and we're done. And it is a review of exponent rules. Okay, that's got the 0 number. And but we have already kind of started exponentials, but we're going to get into where we need to use some of these rules some more. And again, these are a review. We probably kind of talked about some of them along the way. Anyway, number one's a biggie, and it's one that I think you do completely understand. However, we're going to start using it backwards. And one of the reasons I want to review this is because I don't think everybody always makes the connection that you really do know how to do it and it's the same thing. Because you've probably never had to do it backwards. So we know that if we have a product, okay, A is not 0 because if it was, the whole thing would be 0. But if I'm going to multiply two terms with the same base, I keep the base and I add the exponents, right? We know how to do that. So we're going to do a few examples so we can make sure we really know that we do know this. So for the first one, let's do x to the 5th times x to the 7th. And I'm pretty confident that we know that this is not x to the 35th, right? We add them and we get x to the 12th, right? Old news. We're good at that. Okay, so then let's do another one. What if I had x to the negative 6th times x to the 10th? Now, we do have rules for negative exponents. We haven't talked about them yet today, even though they're not new. But we don't have to do negative exponent things. We can actually use the product rule here, keep the base, add the exponents, and what do I get? 4. So it's just x to the 4th. And you don't have to do any fancy negative exponent stuff. Everybody good with that? Okay, so then what if I have 3 to the x plus 3 power? Now, I can't combine anything because there's nothing to combine, right? But I want you to think about the fact is if we have a rule that if we're multiplying two things with the same base that we add the exponents, then if I have in the exponent I have some addition, I can go backwards and split it up. So that means that this is the same thing as 3 to the x times 3 cubed. Does that make sense to you? Because if I gave you this, we would keep the base. We would not multiply the 3's together. We would keep the base, and we would add the exponents, right? So it is the same rule that you've already known and been doing. You may have never had to go backwards before. Okay, so if I can take these two and add them together, if I have addition, I can split them back apart like this, okay? I'm not taking like the square root of 3 or anything. The bases are the same, just like they were with x or with anything else. And then I can go a step further to simplify this. What is 3 to the 3rd power? 27. So this can become 27 times 3 to the x power. And now that is in the a times b to the x format that we were looking at for exponentials. Okay, so this is the big one for today. We're going to talk about the rest of them because they come up in a lot of things. But understanding, because you're going to have to do this, and I mean, this is something that helps you simplify some things even in calculus, so it's not just for us just right now, but just like moving forward, understanding how these things work in both directions. We good? Okay. So then let's look at power to a power rule. If so again, a is not 0, the whole thing's 0. Here, power to a power, that's when you multiply them. So this would become a times, a to the m times n power. So if I have x to the 5th to the 3rd power, this is when you get to multiply them and get x to the 15th. Okay. Then if I have p cubed to the 1/3 power, what would that give me? P, because I'd multiply 3 times 1/3, and that's 1, right? So this is just P. Another way to write that, just to kind of connect this all together, is the cube root of p cubed, right? So we know if we have p cubed and we want to undo it, we would do the cube root. But remember, the cube root and the 1/3 power, same thing, okay? So we're not really talking about roots today, but we need to kind of remember that. And that's why you end up just getting p. But that's how it works with the exponents, okay? Any questions about that? Awesome. So then we have product to a power rule. So, and it says product. That's important, product. So inside here I have one term. And they're being multiplied, so then I can take that m and I basically distribute it to each of the variables in there, or numbers, or whatever they are. So it'd be a to the m times b to the m. Here's what it is not. If I have a plus b to the m power, this is not a product. Do you see how this is different than this? This is one term, this is two terms. So I get to distribute the m here. I do not get to do that here. This does not equal a to the m plus b to the m. That gets you thrown in math jail real quick, okay? And that's a very common mistake, and that's where sometimes I think even here, when you know what to do, you overthink it because you get this wrong all the time. But so make sure you understand how they're different and when you get to do that. Okay, are we all good? Alrighty. So then, let's see. Let's start with x squared times y cubed to the 3rd power. So I'm going to use my product to a power and my power to power rule at the same time. So if I'm going to get to distribute this 3 to both of them, that means I have x squared to the 3rd power. So I get to multiply my exponents. That gives me x to the 6th times y to what? The 9th. Okay? Everybody okay with that? Because we want to make sure we're not making up math when these things come up. Alrighty. Next one then. Let's do 3x to the 4th to the 3rd power. Now, I'm going to do a middle step that you don't necessarily have to do. Some of you may choose to do it so you don't like do anything crazy, weird, and wrong, but you may not all need to. But I'm going to actually do this step in here. So when I do that, this is going to give me 3 to the 3rd times x to the 12th, right? Because I'm putting it on both of them. What is 3 to the 3rd? 27. I didn't want anybody to wonder magically where 27 came from, so. Any questions about that at all? All right, and then a big place where this gets applied, like I think when it gets applied here, you don't necessarily have that much of an issue, but when this thing comes up, I get a lot of the looks, or I get weird answers, and I get people just having no clue what to actually do, but it's the same thing. I have no addition and subtraction. If I did, totally different rules. But here, and again, I'll do the kind of the middle step here, but I'm going to take this squared and put it on both of them. This is going to give me 3 squared times the square root of 5 squared. The other thing that happens here is you try to avoid that and then put it in the calculator, and the majority of the people that do that put it in the calculator incorrectly, and then you just believe what the calculator said because, I mean, it's the calculator. But it's only as accurate as what you type in. So 3 squared is 9. What's the square root of 5 squared? 5. And then my answer is 45. That's something we got to be able to do by hand. Okay, does that make sense? Do you see how you tie it to everything else we've already understood, right? Okay, good deal. 0 exponent. All right, what's a to the 0? 1. Okay, so let's look at a couple of different setups here. If I have 5x to the 0 power. And again, I'm going to put a couple extra steps in there you wouldn't necessarily have to put in there, just so that we can have a discussion about some of this. But if I'm going to actually follow all these rules and show every single step, which again is not always necessary, I would do my product to a power rule, which would give me 5 to the 0 power times x to the 0 power. What is 5 to the 0 power? 1. What is x to the 0 power? 1. And then 1 times 1 is 1. Now again, is all of this right here, do you have to do it? No, because if this whole thing's to the 0 power, it goes to 1. But did kind of have a reason I wanted to do that. So, but then if I have 5 times x to the 0, see how it's written differently than the first one? On the first one, that 0 gets applied to both of them because it's in parentheses. Here, does that 0 apply to the 5? No, it does not. So this is really just 5 times 1, which is 5. Because again, most of the mistakes made with exponents is not that you're completely clueless about it. It's careless mistakes or not paying attention to parentheses and things like that, or, overthinking it. Alrighty. Quotient rule. So when we multiplied, we took the exponents and we added them. So when we're dividing with the same base, we take the exponents and we subtract them. Oops, something like that. Okay. So I could have x to the 12th over x to the 5th. The base stays the same, even if it's a number. If I had 2 to the 12th and 2 to the 5th, then I would have 2 to the whatever. What's 12 minus 5? 7. Then, what if I had x to the 5th divided by x to the negative 1 power? Now again, there's certain things we can do with the negative exponents, but we're going to kind of ignore that rule right now and just use our quotient rule. We don't have to know anything about negative exponents. We know that we are dividing, so we keep the base and we subtract. What do we get for an exponent? 6. Very good. And I'm going to show you, because I'm not sure, maybe you do get shown this when you first do it, but a lot of times when you're first doing stuff, you really don't know what you're doing yet. So when they show you the y, it really doesn't make any sense. But so let's do something super simple here. If I have x to the 5th over x squared, okay, we know that's x to the 3rd, right? But if I was going to write it all out, which I, definitely don't want to do every single time, but if I did, then what this means is I have 5 x's being multiplied in the numerator, right? And I have 2 x's being multiplied in the denominator. So then when I reduce, these 2 cancel out with these 2, which leaves me with 3, which is x cubed. So that's basically what's happening, is you're reducing it that way, literally by canceling things out, but instead of writing it all out and canceling them, it's the same as subtracting. Okay? What questions do we have? Anything? Awesome. All right, so then we have quotient to a power rule. A and B, again, can't be 0, or it would be undefined, or the whole thing would be 0. But you're basically just distributing it again, so this is going to be A to the M over B to the M. So here's a couple of examples. Let's do x squared over y to the 3rd power. Okay, so it's a quotient to a power rule, but then we're also doing power to a power, because that would mean I would have x squared to the 3rd power. That would give me x to the what? 6th. And then I also have to take y to the 3rd power, which is y cubed. That's why when you have a fraction to an exponent, you have to have parentheses. Otherwise, the exponent really just goes to the numerator. But when you put the parentheses there, it goes to both. We all good? All right. So then let's look at x over 2 to the 5th power. Okay. So once again, I'm going to do a middle step, which you wouldn't necessarily have to do. I'm going to just go ahead and straight up do this, which gives me x to the 5th over 2 to the 5th. X to the 5th just stays x to the 5th. What is 2 to the 5th? Not 10, but 2, 4, 8, 16, 32. So I get x to the 5th over 32. Any questions about that? That makes sense? Okay. If that makes sense to you, and I think it has made sense to you, then when you have just straight up fractions with numbers, that should make sense to you too. But that's also when your brain starts to power down, because you see a fraction and you think it's difficult, or you just think you don't like them, and it just, is what it is. But if I have 2/3 squared, squaring a fraction is easy. Fractions get more complicated when you're adding and subtracting. But multiplying, dividing, squaring, all that stuff's really not that bad. If I just straight up apply this first, this would give me 2 squared over 3 squared. So if you're going to square a fraction, all you're doing is squaring the numerator, squaring the denominator, and that gives me 4/9. And that is not that big of a deal at all. Okay? So just making sure we're all confident in that. We good? Okay. Now let's look at negative exponents. Negative exponents give us reciprocals. That's one way to look at it. This is worded a little bit different. It says base to a negative power moves from numerator to denominator or vice versa. Well, if you don't have a fraction, you can always make a fraction out of something by putting it over 1. Okay? And then you can literally move what's in the numerator to the denominator, or think about it as a reciprocal, and we get 1 over a to the positive m power. And then if I have a negative exponent in the denominator, then it moves to the numerator, and we change the sign. Oh my gosh, this board. Okay, I think it's going to have that weird line there no matter what I do. It's one of those things, yeah. So we're just going to leave it. Here, let me change colors so we can see it then. This would just be a to the m power. And you don't have to put it over 1. You can, and there's nothing wrong with it. You wouldn't see it that way, and you don't need to. But if it kind of finishes it off for you so you don't get confused, totally fine. Okay, we all good with that? All right, so we're going to do quite a few of these because I want to talk about a couple of different things. So if I have x to the negative 3 power, that would become... So again, we can just think about it as the reciprocal, or we can think about that moving to the denominator, be 1 over x cubed. That does not look like a cube, but cube. Make my 3 a little bit better. Okay. Yes? That makes sense, yes? Okay. So then, second one, if I have 1 over x to the negative 4th, then I can take, since it has a negative exponent on it, bring that to the numerator and make it x to the 4th. And since there's nothing left in the denominator, again, you could put it over 1 or you could just leave it. Whatever works for you. All right. So then, if I have 1/2 to the negative 2 power. So I'm going to do an extra step that some of you will want to do. Again, you don't have to if it totally makes sense to you and you're comfortable with it, but I'm going to deal with the negative first. Okay? So the negative being on a fraction, instead of really thinking about it moving from numerator to denominator, I'm just going to think about I want the reciprocal. So the reciprocal of 1/2 is 2. That changes my exponent to a positive 2. So then I have 2 squared, which is 4. Okay? That makes sense? So we know what to do with those. All right, and then along the same lines there, if I have 3 to the negative 2 power, I can think about moving that 3 to the denominator, right, which that would make that 1 over 3 squared, which gives me 1/9. Okay. Couple of more. Let's see. What if I have x to the negative 2 power, y squared, z to the negative 3 power? Okay? So the first thing I look for is addition and subtraction. And if I have any of that, then I have to play by different rules. Okay? I still might get to use some exponent rules, but it's not going to be as straightforward as this. There's no addition and subtraction, which means I can freely move things from the numerator to the denominator. I'm going to make myself a fraction bar. All right, that x to the negative 2 power, that gets moved to the denominator, yes? So this is my x to the negative 2. So I've taken care of that guy. Y squared, it's not negative 2 anymore. Goodness. It's regular 2 because I moved it, right? Y'all weren't even going to stop me. And then this y squared, does he move anywhere? Nope, he stays there. Does the z move? Yes, it moves to the numerator. The 3 stays the 3, but it becomes positive. Okay. Any questions about that? We're all good on that one? Okay, So then, one more. Let's say I have x to the negative 2 power over y squared. Okay? So again, I'm going to start by putting my fraction bar. That x to the negative 2 moves to the denominator, and it's just x squared. Y squared stays down there. Am I done with my answer as it is? No. But if I hadn't put the fraction bar there, some of you would be done, and you'd box your answer and be like, oh, it's x squared times y squared. But that doesn't make any sense, right? What goes in the numerator? 1, exactly. So I think it's safer to like put the fraction bar, and then if you end up with nothing, you put a 1 there. And if you end up with nothing in the denominator, you can either put a 1 there, or you can just get rid of the fraction bar. It doesn't matter either way. Okay? Everybody good on that? Any questions? All right, so this goes on page 53, but I want you to turn to page 52 real quick. We're going to work backwards a little bit. When I'm done up here. All right, page 52 in your ISN, that means you need to get it. Get it, get it, get it. Page 52 is your title page for the third 6 weeks. It can be little, it can be big, but that's all you have to write there. Third 6 weeks. Okay? Then you back up one more to page 51 because that should be blank, right? And on page 51, that is your second 6 weeks reflection. And it's pretty open-ended. Last time y'all's was all pretty short because I didn't give you much time to write. So I would prefer more than one sentence. Like, I don't know, you don't have to fill up the whole page, whatever. But reflect on your performance in here in the second 6 weeks. Better or worse than the first 6 weeks, or the same? Would you change anything moving into the third 6 weeks? You know, whatever. Just, it's your reflection, but I want to give you some time to reflect on that, okay? While you're doing that, I'm going to hand out your assignment, and then I'm also going to give you your calendars after I print them.